All right. Good evening, children. Good evening, Srijit.
Yes, ma'am. Good evening, ma'am.
Yeah. So before we discuss the answers to the homework questions, we'll just do. We'll just take a small test, okay, and then discuss the answers. Yeah. So take down what you see on the screen in your book, Srijit. Yeah. What's the answer? You can draw later. Fine. Start. See, you must catch up with my pace. Yes, you stop. You can look at the figure on the board and answer the questions. Leave some space to draw the diagram. Quick. Quadrilateral PQRS is a write the statement and answer the questions. Hi, good evening. Yeah, quadrilateral PQRS is a yes, quick. Kite. Very good. It's a kite. Angle POS is equal to. Very good. Angle POS is equal to 90 degrees. Srijit, you have to answer. I need not call out your name. You can just give the answer.
Okay, ma'am.
Yeah. Yes, diagonal. Diagonal PR. Very good. Bisect the diagonal.
PR and the QS, ma'am.
Very good. This means what? This means what is equal to what?
PR.
Diagonal PR bisects diagonal QS. This means what? What do you understand from this? This means which one is bisected? That means what is equal to what? Sorry? QS is equal to PR. Huh? What have we learned? Are the diagonals of a kite equal? No. Then how can PR be equal to QS? The diagonals of a kite are unequal. QO is equal to OS. QO is equal to OS. Which diagonal is bisected? QS is bisected. It's cut into two equal pieces. So the two equal pieces are QO and OS. Yeah.
QOOS.
Yeah. Angle 1 is equal to angle 3. Very good. Angle 1 is equal to angle 3.
Angle 3, ma'am.
Okay. Angle 4 is equal to angle 2. Angle 4 is equal to. Correct. Then tell me one more pair of equal angles, Srijit. One more pair of equal angles.
Ma'am, 5 and 6, ma'am.
Angle 5 is equal to angle 6. How do you, use 3 letters and name angle 5? How do you name angle 5? Angle?
Q, ma'am.
No, use 3 letters. Use 3 letters. Use 3 letters. PQR, angle PQR is equal to angle
PSR.
PSR is equal to angle PSR. Angle PQR is equal to PSR. Correct.
Yes, ma'am.
Angle 5 is equal to
Angle 6,
angle
ma'am.
5 is equal to 6. 5 is equal to 8. Angle 5. Why is angle 5 equal to angle 8? Angle 5 is equal to angle 8. Correct. Angle 5 is equal to angle 8 because not opposite sides are equal. In a triangle, when two sides are equal, the angles opposite to them are also equal. In a triangle, when two sides are equal, the angles opposite to them are also equal. See, it's because I'll draw that figure alone for you. See here, this is the triangle. Look at the board, all of you. Look at the screen, Srijit. PQS, okay? PQS, in triangle PQS, PQ is equal to PS. Okay, PQ is equal to PS. So in a triangle, when two sides are equal, the angles opposite to them are also equal. So the angle opposite to PQ is this one, this angle S. And the angle opposite to PS is this angle. PQS is an isosceles triangle. PQS is an isosceles triangle with PQ equal to PS, correct? So since these two sides are equal, the angles opposite to them. It's very easy. See now, PQ, no, leave those two letters P and Q. Which is the third vertex? S. PQS is the triangle. The side is PQ. So which is that letter? The other letter, S. So this angle is the opposite angle. Opposite to PQ is angle S. And what is this side? PS. Which is the other letter? Q. So opposite to PS is Q. Very easy to make out. See, PQ is a side, no? PQ is equal to PS. Opposite to PQ is PQ. So the other letter, S. S. And opposite to PS will be PQ. Not PQ. Q. Angle Q. In a triangle, when two sides are equal, the angles opposite to them are also equal. So we have angle 5 equal to angle 8. Correct? Yeah. Now name the other isosceles triangle in the kite. The other isosceles triangle in the kite is
QSR.
QSR. QSR is the other isosceles triangle. These two sides are equal. So which is the angle opposite to QR? Which is the angle opposite to QR? Please come in and sit there.
Yes, sir, ma'am.
Fast, settle down. Yeah, which is the angle opposite to QR?
7, ma'am.
Very good, 7. And which is the angle opposite to RS?
6, ma'am.
So you should see in the figure we have in triangle QRS, we have this line segment RO coming in the middle, no? So don't get disturbed by that angle, that line segment. See, I've drawn the triangle here for you. We have learned that the shorter diagonal in a kite divides it into two isosceles triangles. In a kite, the shorter diagonal divides it into two isosceles triangles. One is small, the other will be big. Okay, different sizes it will be. The longer diagonal divides the kite into two congruent triangles, identical triangles. If you fold the kite along the longer diagonal, the two triangles will coincide. They're identical, they're congruent, they're identical. If you fold the kite along the longer diagonal, the two triangles on either side of the longer diagonal will coincide. Okay, so the longer diagonal divides the kite into two congruent triangles or identical triangles. The shorter diagonal divides the kite into two isosceles triangles. These two isosceles triangles will not, look alike, like one will be small, the other is big. They'll have different sizes. They'll not be identical. They're not identical, but both are isosceles triangles. Both are isosceles triangles. So see the triangle alone. See, the triangle is QRS. In this triangle QRS, these two sides QR and RS, they're equal. So opposite to RS is angle 6 and opposite to RQ is angle 7. These two angles are equal. Why? In a triangle, when two sides are equal, the angles opposite to the two sides are also equal. Yeah, you can't say that because if these two sides are equal, these are not the base angles. Yeah, take down, children. Yes. Yes, still to discuss. See the first figure, it's incomplete. Rajat, are you writing?
Yes, ma'am.
Yeah. Yeah.
G, A, B, C, D, F, G, H means that question not in the right question.
Yeah, yeah.
Then we have to separate it by triangles.
No. I have just drawn to explain. I've drawn triangles to explain. Yeah, you can draw actually. See, the question is angle phi is equal to dash. That's the question. I have drawn the figure to explain. So you can also take it down. Yeah, done. So we have to be faster, children. Practice writing. Take a small paragraph from your English textbook. If you have not received this year's textbook, use newspaper, any material, and set the timer and write as much as possible in 5 minutes. Next day, write the same paragraph in 4 minutes, 3 minutes. Improve your speed. Yeah.
I'm lost.
Yeah. Done, Srijit?
I'm going to finish my
Yes. Yeah, done, Srijit?
yes, ma'am.
Disable your mic. Please unmute only when you have to say something.
Okay.
Same figure with the diagonals here. So you also draw two figures like this. Yes, quadrilateral ABCD is a trapezium. Why the others didn't answer? Huh? Why?
And trapezium.
You should be the first to answer. You should not be late. What about the others here? Yeah, fill in the blanks. AC dash BD.
Bisects.
Sorry, Srijay, again?
Bisects.
No. No. No, you can't. No. What do you know about the diagonals of a trapezium? AC and BD. What do you know about the diagonals of a trapezium? What can you say about the diagonals? If they are equal or not equal, right? Yeah, in a trapezium, the diagonals are not equal. In an isosceles trapezium, the diagonals are equal. In a trapezium, diagonals are unequal. If it's an isosceles trapezium, then the diagonals are equal. So here AC is not equal to BD. AC is not equal to BD. Correct? Yeah. You can see now, where do you have the diagonals? Yeah, use that figure. That's it. Same. One is with the diagonals, one is without the diagonals. Turn off your camera, Srijit. Yeah, next one, angle ABC plus. B. You can give a different answer. I didn't acknowledge the answer. Yes, Srijit, for C, angle ABC plus dash is equal to 180 degrees. So last year we have learned no parallel lines transversal. Okay, parallel lines transversal, co-interior angles are supplementary. So these two lines are parallel. BC is a transversal. These two lines are parallel. See here. See, the trapezium is here. These are the parallel lines. This is like this is the trapezium A, B, C, D. This is the trapezium. Okay, so these are the two parallel lines. This is a transversal. BC is a transversal. This angle plus this angle is equal to 180. Co-interior angles are supplementary. Similarly, this angle plus this angle is equal to 180. Co-interior angles are supplementary. Parallel line, transversal, parallel line. It should be like that. Parallel line, transversal, parallel line. Co-interior angles. Co-interior meaning C, no? So it will be found in that C shape. Co-interior, CO, C. So C, like this. Can you just look at this one as C? Do you feel this is something like C? Yeah. So these are the parallel lines. This is the transversal. These angles will add up to 180. Very easy to make out. You should just find the C. And then in that C, these two should be the parallel lines. And this should be the transversal. So this angle plus this angle is equal to 180. Yeah. So see here, I'll draw it again for you. Parallel lines, transversal. So this is the trapezium A, B, C, D. These two lines are parallel. All right. So see here, parallel line, transversal, parallel line. The sum of these two angles is equal to 180 because they're co-interior angles. So this angle plus this angle. Similarly, this angle plus this angle because parallel line, transversal, parallel line. When you see the C, how will you, what will you say? Parallel line, transversal, parallel line, or parallel line, transversal, parallel line. Okay. So when you draw a C like this, these are the two angles. So there are only two angles there. You can't find more than that. There are only two angles. The sum of these two angles is equal to 180 degrees. So now look at the trapezium here. Look at the trapezium. Can you see parallel line? I'll use a different color. Here, can you see parallel line, transversal, parallel line? Correct? So which are the angles? This one and this one. So angle ABC plus angle BCD. Angle BCD is equal to 180. Because the reason is why? Why? Because co-interior angles are supplementary. Yeah, what's answer for the next one? BAD. Correct. BAD. See here? Here. Or if you look at the board, see here. Now this is the parallel line, transversal, parallel line, transversal, parallel line. So in that, see, these are the two angles, this one and this one, right? This angle and this angle. In that, see, we have these two angles. So the sum of these two angles is equal to 180. So I have given ADC already, which is the other angle, BAD or DAB. That the vertex of that angle, that vertex, that should be in the middle. This angle A, you can call it BAD or DAB. Put A in the middle. Where the angle is formed, that letter you should put it in the middle. Where is the angle at A? So you call it DAB or BAD, but A should be in the middle. Okay. Then next, which are called the bases? AB and very good. AB and DC, which are called the legs? AD and BC. Okay. Then AE dash EC. See, you can use a word or you can use a symbol. Less than, greater than, equal to, not equal to. You can use it. Not that you should, fill in the blank with a word. You can use symbols also, yeah? Or you can say parallel, not parallel. See, these are the things you can use. You can use parallel symbol, not parallel, equal to, not equal to, greater than, less than, if needed. Yeah, now AE. All of you? AE is not equal to EC. BE is not equal to ED. Because the diagonals of a trapezium do not bisect each other. The diagonals of a trapezium do not bisect each other. The diagonals of a trapezium, they don't bisect each other. E is not the midpoint of AC and BD. E, note, E is not the midpoint of AC and BD. It's not the midpoint. You improved your speed. Good, you've improved your speed, I said. Yeah. Have you drawn the figures? Have you labeled them? Midpoint. No, you all said AE is equal to EC and BE is equal to ED, no? So I've just written that note for you. E is not the midpoint of AC and BD. Don't understand that? They don't bisect each other. Only if they bisect each other, E will be the midpoint of both the diagonals. They don't bisect each other. So E is not the midpoint. So A is not equal to EC. It's a scaling trapezium. If nothing is mentioned, it is a scaling trapezium. Meaning if you don't find any other property, you just see one pair of opposite sides parallel. You just find one pair of opposite sides parallel, no other information. So it's a scaling trapezium. Yeah, tell me quickly. I want the best answer for this. I don't want an answer. I want the best answer. No, that's not the best answer. That is a correct answer, but I want a still better one. Correct. AD is not parallel to BC because it's a trapezium. Put parallel and flash it like this. AB is not parallel to BC is the best answer. Huh? Yeah. AD is not, you can say anything after the class, not now. AD is not parallel to BC. All right. This is the best answer. எல்லாரும் ஒரே ஃபிகர் வரையலாம் ஆனா அதுல ஒரு ஃபிகர் பெஸ்ட்ன்றோம்ல எல்லாரும் அதே தான் வரைஞ்சிருப்பேன். Everybody have drawn the same thing. Suppose Indian flag. எல்லாரும் கரெக்டா வரைஞ்சிருப்பேன். எல்லாம் கரெக்டா, but one will be the best, right? So AD is not parallel to BC because it's a trapezium. A trapezium is a quadrilateral in which one pair of opposite sides is parallel and the other pair of opposite sides is not parallel. Why, Srijit, you're quiet? Are you there? Yeah, GH is called the median. GH is called the median. All right. Now, in this trapezium, can we say that angle DAB plus angle ABC is 180? Let's analyze using the figure. Let's try to draw that C and analyze DAB and ABC. So we are talking about this angle, no? We are talking about this angle. This is DAB, right? Huh? and ABC is this angle. This is ABC. So let's draw the C, which contains those two angles. Okay, so those two angles are in this C, right? DABC. We're talking about this angle DAB, correct? DAB and ABC, this one. Okay. Yeah, it is in a C kind of formation, but is this parallel to this? No. So the sum of these two angles is not 180 because they're not co-interior angles. So it's not some C formation. In that C, you must have these two lines parallel. Then they are not co-interior angles. Sorry? Two parallel lines and one transversal. Yeah. So here, the sum of these two angles cannot be 180. It's not 180 because this one is not AD is not parallel to BC. So they are not co-interior angles. So you don't have to write this. I just. Okay, next. In the blank, see, I normally give only one blank, but you can write more than one word. If I give three blanks, then you will know that, okay, some three words must be filled. So I will not give three blanks. You can write more than one word in a blank. You understand me? There's only one blank, but you can write more than one word also. Yeah. Yeah. So quadrilateral MNOP is an It's an isosceles trapezium. Why is it a trapezium? Because one pair of opposite sides are marked parallel. So it's a trapezium. And it's isosceles because the non-parallel sides are equal. Hear me out. Why is it a trapezium? Because one pair of opposite sides are parallel. That's why it's a trapezium. And then why is it an isosceles trapezium? Because the non-parallel sides are equal. Yeah. Yeah, children. So I repeat because I don't know where I stopped. This quadrilateral we identified as a trapezium because one pair of opposite sides are marked parallel. Okay, so we call it a trapezium. And we call it an isosceles trapezium because the non-parallel sides, MP and NO, the non-parallel sides, they're marked equal. See here, they're marked equal. So it is an isosceles. Isosceles trapezium. What is this, children? Huh? Diagonals MO and NP dash each other. They do not bisect. See, in a kite, the longer diagonal bisects the shorter diagonal. In a trapezium, the diagonals don't bisect, whichever trapezium it is, whether it is scalene, right, or isosceles. In a trapezium, the diagonals do not bisect each other. There's something called proportional. They divide each other proportionally. Next class, I'll tell you that. I'll not stuff you with too much of information. So there is something else with the diagonals. They divide each other proportionally. The ratio will be the same in an isosceles trapezium. Okay, let's not go into that now. In a trapezium, the diagonals do not bisect each other. Whether it is a scalene trapezium, isosceles trapezium, or a right trapezium, the diagonals do not bisect each other. But in a kite, the longer diagonal bisects the shorter diagonal. And in a parallelogram, rhombus, rectangle, square, the diagonals bisect each other. Okay, we have learned 6, meaning kite, trapezium. Okay, now forget the subdivisions in the trapezium. So kite, trapezium. Then parallelogram, rhombus, rectangle, square. Okay, so parallelogram, rhombus, rectangle, square, the diagonals bisect each other. In a kite, longer diagonal bisects the shorter diagonal. In a trapezium, the diagonals do not bisect each other, whether it is scalene, isosceles, or right trapezium. They don't bisect each other. So they divide each other proportionally. Something else does. Yeah. In an iso, the next. Okay, so here's the second one. Diagonals MO and NP do not bisect. Do not bisect each other. Diagonal MO is equal to diagonal NP only in an isosceles trapezium, not in every trapezium. Because it's an isosceles trapezium, the diagonals are equal. Angle PMN is equal to this. This I don't know if I've told you. So in an isosceles trapezium, this angle is equal to this angle, and this angle is equal to this angle. In an isosceles trapezium. See the positions. Okay, so now tell me, we're using this figure, tell me angle PMN is equal to? O
PM.
in D, yeah. Angle PMN is equal to N, no. Use this figure, children. Huh? You compare and tell me. Huh? Use this one. I've marked the equal angles. Don't look at me. Look at the board. ONM. ONM. See this angle. See here, children. This angle I said is equal to this angle. These two angles. So name this angle is equal to this angle. How do you name it? PMN is equal to ONM or MNO. Yeah, then NOP is equal to
FPO.
this angle is equal to this angle. So angle NOP. Huh? NOP is equal to correct. MPO. MPO. This is only in an isosceles trapezium. Okay. In an isosceles trapezium, the non-parallel sides are equal, the diagonals are equal, and see the angles in these positions. We have two pairs of equal angles. We have two pairs of equal angles. So in an isosceles trapezium, diagonals are equal, non-parallel sides are equal, and the angles in these positions, these two pairs of angles are also equal. Apart from this, we have supplementary. Yeah, not adjacent angles. No, you can't say in a parallelogram, adjacent angles are supplementary. Here, which are co-interior angles are supplementary. Tell me. Let me mark it here. M, N, O, P. Co-interior angles, children. Louder, confidently and loud.
NPO plus
NPO. NPO plus. Did you say NPO? Ah, then. NPO எங்க angle? Okay. MPO and NOP. Where's the C? Where's the C? For coincidence, see when two angles add up to 180, they are co-interior angles. Which are the parallel lines? Which is the transversal? Where is the C? Which C are you taking? P? PMN and which angle? Oh, these two angles, huh? Oh, you see, I'll tell you one thing. You can give any answer, give it confidently.
Yeah,
You're asking me or you're telling me? Okay, is this right?
Yeah.
MPO plus, which is the other pair? Correct. These are the parallel lines, right? These are the parallel lines. So see a parallel line, transversal parallel line. Let's mark it here. These two lines are parallel, correct? Yes or no? Can we see the C there? Parallel line, transversal parallel line. Okay. Is this a C formation? C. And these two lines are parallel. This is a transversal. And there are two angles here. No, the sum of these two angles is 180. And how do you name them? NMP or PMN. PMN. And then how do you name this angle? MPO or OPM is equal to 180. And for the next one, these two angles, MNO and PON. This also I'll just write in a different order. I'll write NMP and MPO. Only when you're sure about the properties, I told you this in the previous sessions also. You must know the properties very clearly without any doubt. Only then you can, solve the questions from this chapter. It's all based on the properties. Sridhar, why I'm not hearing from your end? Done? Okay. What's the second figure? Yeah. Yeah. Okay. No, see, the figure should be wherever you've written this theory part, you should have the figure there. You don't need it actually. It's okay. You draw a small one beside that itself. Beside the first figure itself. No space at all. With the diagonals, you draw it again, children. Draw the figure again with the diagonals. Yeah, quadrilateral CDEF is a parallelogram. Why no answer from you and you? When you ask a question, you must answer. You must stop your work and answer. No.
The parallel.
The corners, do they look like right angles for you? No, right? The quadrilateral CDEF is a parallelogram. CD CD is parallel to EF and CD is equal to EF. In a parallelogram, opposite sides are parallel and equal. And equal. So tell me for what shall I give us the next one? Similar to B. No, give me the next one. Form a question similar to B. Similar to B.
CF is CF dash.
Yeah, CF dash DE and this was done in the last class. All sides are parallel. All sides cannot be parallel. Only opposite sides can be parallel. All the sides cannot be parallel.
Yeah. CF is parallel and is equal. And we not just right.
What sign? In a parallelogram, both the pairs of opposite sides are parallel. I have marked, no? I have marked there. That's why you called it a parallelogram. Why did you? If I use a single-handed arrow for everything, then how will you make out which are the parallel sides? If, yeah. No. If I have not, no, now I'm going to ask you questions. I have not, see, I've marked, given the arrowheads for you to name the quadrilateral. If I don't give you the arrowheads, then how will you say it's a parallelogram? I've used single arrows and double arrows to show the parallel sides. So since in the figure, you see that both the pairs of opposite sides are marked parallel. That's why you called it a parallelogram. Now your question is why you have not marked the equal angles. No, that you will tell me now. I have marked the parallel line so that you can name the quadrilateral. Okay. Now, angle 1 is equal to what is the property in a parallelogram? We are talking about angles. Opposite angles are equal. Which are the opposite angles? They are adjacent angles. 1 and 9 are adjacent angles. 1 and 9 are adjacent angles. What do you mean by adjacent and opposite angles? Adjacent angles are angle 1 and angle 9 are adjacent angles. 1 and 7. And angle 4 is equal to 9. Opposite angles are equal. You started school today, is it? For you 8th, no? B section last year. B. Okay, next. Huh?
I'm also
B section. Okay.
first.
Hmm? Because he's studying well.
Oh, it's not.
Okay. Fill in the blanks. See, you people identify the parallel lines and transversal. What is that you're blinking? So which is the C? Like this, huh? One minute. Angle? 1 plus 4. Angle 7 plus? That's all? Here you can form 4 C's. Here we can form 4 C's. 1 and 9. Navneet, you should know when to listen and when to write, Navneet. When we are discussing, you can write later. When we are talking, when we are discussing, you should stop writing and listen to the class. See, in a parallelogram, this is a C formation. See, this is the parallelogram. This is parallel to this. This is parallel to this. Okay, correct? So see here, you can form a C like this, correct? Where A, B, this is parallel to this. So these two angles are co-interior angles. You can make when you rotate the C, it becomes a U, no? When you rotate the C, it becomes a U. So can you see this one? A, D, C, B, where this is parallel to this one. And this is a transversal. So this angle plus this angle is 180. Then you have like this. D, A, B, C. Again. Yeah, correct. So when you rotate the C, it look like U, an inverted U. So this is like a U. This is an inverted U. This is an ulta C. This is C. You can see the C formation and ulta C. Then you can see a U kind of and an ulta U. Yes or no? Okay. All right. Why do you look at your friends for their reactions? Yeah. Fine. So you will find 4 pairs of co-interior angles that are supplementary. 4 pairs you'll find. We find 4 pairs of co-interior angles that are supplementary. So tell me the other 2 pairs. 1 plus and adjacent angles. Correct. Which one? 1 and 9. Okay, fine. So opposite angles are equal. In a parallelogram, opposite angles are equal. Adjacent angles are supplementary. You find 4 pairs of co-interior angles. All right. Yeah, so we'll start with Sriharni. Sriharni, mention 1 pair of parallel lines and the transversal. See, okay. All right, we'll do it like this. So Sriharni, for this one, you tell me, for this result, tell me the parallel lines and the transversal. For 1 and 4, angle 1 and angle 4. Name the parallel lines and the transversal. Loud, loud. See, we have written this. All these 4 results are correct. Now, for angle 1 plus angle 4 is equal to 180. Which are the 2 parallel lines and which is the transversal? No, don't do that. See, you should never do it. Put your hand down. Is it? Did I ask you? No, don't disturb. So she will. Huh? Parallel. No. You should say the parallel lines. The parallel sides. 1 and 4. 1 and 4. Which are the parallel lines? See the C. And the C cooler 1 and 4. E. EF is parallel to which one? CD. And which is the transversal? No. CF is a transversal. CF is a transversal. 1 minute. I'm just bringing the same figure here. You don't draw it again. Yeah. EF is parallel to CD, and which is a transversal? FC or CF is a transversal. Is a transversal. So the sum of which 2 angles is 180. Angle plus angle is equal to 180. Next, Anirudh. Mention anything. Mention the parallel lines and the transversal. Okay, 1 minute. For the same 2 parallel lines, EF parallel to CD, tell me another transversal. ED is a transversal. ED is a transversal. So, correct. Yes, Navneet. Next pair of parallel lines. No. Excuse me. Yeah, Avanish. The other pair of parallel lines. Okay, let me 1 minute. Let me just give you some time to think. You're ready, no? Both. Don't raise your hand. You're demotivating others to think. You should not show that you know the answer at all. When I ask you, you can answer. FC is parallel to ED. And which is a transversal? CD is a transversal. CD is a transversal. So which are the angles? Is equal to 180. Yes, the last one. No, they order actually. FC is parallel to transversal. Don't look at your friends. You look at the board. FC. FE is a transversal. Write down like this, all of you. We have written it here. We have written it here. The same results. You make a note like this. Mention the parallel lines and the transversal. You already mentioned, huh? Okay. You have given a diagram. Okay. Yeah, make a note. Yeah. Okay. Are the diagonals equal? Are the diagonals equal in a parallelogram? In a parallelogram, the diagonals are not equal. Diagonals are unequal. FD, EC, FD, the diagonals are not equal. Okay. Done. You can use this figure. Use this figure and answer. So what do you when you say FO is equal to OD? And next one? Yeah, so how do you explain that in words? These equalities, how do you explain in words? Diagonals are unequal. Diagonals are unequal. Yeah. Diagonals bisect each other. That's the meaning. That's how you say. When I say in words, you should not say FO is equal to OD. No, no. When we write these results, FO is equal to OD and CO is equal to OE. When you write these results, how do you get these results? What is that property of a parallelogram which tells you these results? The diagonals of a parallelogram, they are unequal, but they bisect each other. They bisect each other, which means FO is equal to OD and CO is equal to OE. They bisect each other. No, because it was in the previous slide. I just do it again for you. No. So are the diagonals equal in a parallelogram?
No.
And do the diagonals bisect each other?
Yes.
Okay. Then what's the measure of angle FOE? Angle angle FOE. No, fill in the blank. Fill in the blank. It's not equal to 90 degrees. Because in a yes. angle FOE is not equal to 90 degrees. You were right, Anirudh. It's not equal to 90 degrees. Why? Because the diagonals are not perpendicular to each other. So diagonals are not equal. They are not perpendicular, but they bisect each other. In a parallelogram, diagonals are not equal. They are not perpendicular to each other, but they bisect each other. Yeah. It can be. It can be a 90 there. That's in the not in a parallelogram. In a parallelogram, if this one is 90 degrees, then it's a rhombus. All right. Made a note of that angle FOE. The dash is here, not equal to 90 degrees. All right. Yeah. Okay, I'll do it. Yeah, I forgot. I'll do it. Yes. Yeah. So quadrilateral ABCD is a why? Why is it a rhombus? All these lame reasons you don't give if you invert it. Yeah. Why is it rhombus? See, I'm stern because we've already, learned the properties in the previous sessions, and you have the notes with you. If people are expected to come prepared to the class. Why do you call, when you look at this figure, why do you call it a rhombus? Because it looks like that. Looks like. Now, no, see here. Is it a parallelogram? Is it a parallelogram? Because we have marked opposite sides, because the opposite sides are marked parallel, so it is a parallelogram. It's a parallelogram because opposite sides are marked parallel, right? And can you see all the sides are marked equal? So it's a rhombus. If look at this figure. In this figure, what can you mark? If I mark, what should I mark here? This side is equal to this side, and this side is equal to this side. Correct? In a parallelogram, opposite sides will be equal. All the sides are not equal. In a parallelogram, opposite sides are parallel. And only opposite sides are equal. But in a rhombus, opposite sides are parallel. Like in a parallelogram, opposite sides are parallel. But all the sides are equal. See, I've marked here. See it like this. What does this indicate? All sides are equal. I'm using a single dash for all the sides. That means all the sides are equal. But here, see here. This one says these two sides are equal. And this one says these two sides are equal. That is opposite sides are equal.
But the all sides are equal and the opposite sides are parallel.
So it's a rhombus. AC. Yeah. 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 AC dash BD. Not equal. Diagonals are not equal. Diagonals are not equal. Angle DOC is equal to? No, I'll not say equal to. Dash 90 degrees. Equal to or not equal to? Angle DOC. Equal to? You're asking me equal to? You must say, I want the answer from you. Yeah. Equal to. Equal to?
Equal.
Diagonals are perpendicular to each other, right? So DOC is equal to 90 degrees. Which is angle DOC? This one. This one. This is DOC. This is 90. Everywhere it's 90. Everywhere it's 90. Why? Because if one angle is 90, vertically opposite angle is 90. Then linear pair again 90. Again vertically opposite angle is 90. So whichever angle they ask, all the four angles are 90. Then they're not equal. Diagonals are unequal, but they are perpendicular to each other. Yeah. So the diagonals bisect each other? Yeah. AO is equal to OC and BO is equal to OD. Complete this, okay? In right triangle AOD by Pythagoras theorem. By Pythagoras theorem. Completed. In right triangle AOD by Pythagoras theorem. I told you, you can write more than one thing in the blank. Should be specific.
C1 is equal to that CO square plus
Which triangle? AOD. No, 1 minute, 1 minute. I want all of them to think. Come, write it in your book and then tell me. Please write in your book and answer. Yeah, all of you write down. Write the answer in your book and read it out. What's that? You asked me, yes? No, you completed that blank? Yeah. Yes, Anirudh?
A square plus O square is equal to D square.
Is it good D?
Yes.
Okay. What's your answer? I've written there. No, what's your doubt? What's your answer? Same. Which is the in this right triangle? Let's shake the triangle alone. Okay, this is the triangle AOD. AOD. This is 90 degrees. Which is the hypotenuse? This is the hypotenuse because it's opposite of the right angle. So these are the legs. This is one leg. This is the other leg. Leg square plus leg square is equal to hypotenuse square. Leg square plus leg square is equal to hypotenuse square. When it's a right triangle, it's important to identify the hypotenuse, the side opposite of the right angle. This is the right angle. Opposite of the right angle, this is the hypotenuse. Now write leg square plus leg square is equal to hypotenuse square. Leg square, AO square, plus another leg, OD square, is equal to hypotenuse square. DA or AD square. Now, Sriharni, tell me in right triangle, AOB by Pythagoras theorem. Yeah, tell me. AO square plus is equal to B square. Okay, okay. Very good. AO square plus OB square. Yeah. Yeah. Then what about diagonal AC dash diagonal BD? What should I fill in the blank? Say that. Not equal to diagonal AC. Oh, sorry. Sorry. Okay. Yes. Yes, Anirudh, yes. Here it is, no? AO is equal to OC and Diagonals are unequal. AC is not equal to B. Yeah, that is what is D. No, D is that. Got it. Yeah, Navneet? Yeah, when I start talking, you must stop writing and listen. When I'm writing, you also write. Complete the answers. Very good. Okay. Okay. Let's see the answers. PQ-SR. What's a property? Opposites? Parallel and equal. Correct. So PQ is equal to SR, or you can write PQ parallel also. Opposite sides are parallel, opposite sides are equal. Similarly, PS is equal to QR. then diagonal PR is equal to diagonal QS because diagonals are equal. Then angle QR, yeah, the diagonals are not perpendicular to each other. Oh, not equal. So, sorry. The diagonals, they are not perpendicular to each other, which means angle QOR is not equal to 90 degrees. It's not 90. Then, do the diagonals bisect each other? Yes, everywhere. Parallelogram, rhombus, rectangle, square, in all the four quadrilaterals, the diagonals bisect each other. So PO. Correct. Now, okay, guess. Okay, I will see. I'll give an answer for this one. F, triangle 1, triangle 2, triangle 3, and triangle 4 are dash triangles. Equilateral. Are they right triangles? Why? Correct, because the diagonals are not perpendicular to each other. The diagonals are not perpendicular. Only if the diagonals are perpendicular, you will get 90 here, so you will have right triangles. The diagonals are not perpendicular to each other, so they are not right triangles. Okay, then scaling triangles. He is right. Isosceles. The triangles are isosceles triangles. We'll take an example. See, now we know that the diagonals are equal, right? So supposing PR is 20 centimeters, then QS is also 20. Correct? Correct? Okay. So now if PR is 20, how much is PO? 10. OR 10. QS also is 20. Why? Because diagonals are equal and they bisect each other. So it will be 10 here and 10 here. So from this you can make it in triangle 1, two sides are equal. In triangle 2, two sides are equal, 10, 10. In triangle 3, two sides are equal, 10, 10. In triangle 4 also two sides are equal. So since in all the triangles, we have two sides equal. These triangles are isosceles triangles. Isosceles triangles. No, because diagonals are not perpendicular to each other, no? So we can't have right triangles here. Meaning triangles 1, 2, 3, 4 cannot be right. Right triangles. Yeah.
bisects like in the last rectangle question I wrote bisect only use the diagonal.
No, if you say diagonal PR bisects diagonal QS, it doesn't give the complete meaning because the diagonals bisect each other. Diagonal PR bisects QS and QS bisects PR.
And that
Equal to. Not, yeah, just put an equal to.
but can you also make bisects? Because it bisects it.
No, then yeah, it can be an answer. Yes. See, we are just trying to understand the properties. So I'm saying you put equal to. Now your question is, what should I do in the exam? It will be more specific. Or maybe they'll give you options. You have to select one of it. Yeah, so PQRS is a square. Diagonal PR. In a square, the diagonals are perpendicular to each other. In a square, the diagonals are perpendicular to each other. All right. So in right triangle, that's why I didn't write the next one. If I write right triangle, then you can make out it's 90. That's why I didn't write. In right triangle QOR. Okay, 1 minute. Triangle 1, triangle 2, triangle 3, and triangle 4 are dash triangles. Now, are the diagonals equal?
Yes.
Okay. So, if this diagonal is 10 centimeters, if this is 10, how much is it here? And this also is 10, right? So it'll be 5 here and 5 here. So in this triangle, two sides are equal. In this triangle, two sides are equal. In this triangle, two sides are equal. In this triangle also two sides are equal. So they're what kind of triangles? Isosceles triangles. Also, the diagonals are perpendicular to each other. So they are right triangles. So both put together, they are right isosceles triangles. So the triangles are right isosceles triangles. Right isosceles triangles. In a rectangle, they are only isosceles. In a square, they are right isosceles triangles. The other properties, you know, no? Triangles bisect each other. So PO is equal to OR and QO is equal to OS. Now let's see the answers to the homework questions. Where have you done it? Ah, yeah. No, that one we are not discussing today. I'll tell you what we do. One second. Yeah. No pair of opposite sides parallel. Right. Yeah. One pair of opposite sides parallel. Both pairs of opposite sides parallel. Parallelogram. No, parallelogram. See, that's the only property you know. You must understand like that. That's the only property you know. Both the pairs of opposite sides are parallel. That's all you know. Then it's a parallelogram. If you say it's a square, you should also know that all the sides are equal. Both pairs of opposite sides parallel, it's a parallelogram. Because only with this property, what can you say? You only know that both the pairs of opposite sides are parallel. With this property, what can you say? Parallelogram. In a square also, both the pairs of opposite sides are parallel. But you can't say it's a square because you don't know that all the sides are equal. Then two pairs of equal length sides adjacent to each other. It's a kite. It's a kite because that's a definition of a kite. See, two pairs of equal length sides adjacent to each other. I've given that, right? He's not written it. Okay, you can check that later, Navneet. Okay, so I've given that in the definition. Yes. Two pairs of equal length sides adjacent to each other. Kite. Both pairs of opposite sides equal. Both pairs of opposite sides equal. So, see, like very safe answer you must give. Very safe answer is parallelogram. Parallelogram. You're not wrong. See, we're just trying to understand the quadrilateral. So we're just discussing. So if I give you more properties, you can say rectangle also. See, if you suppose if with this property, if you should write the most appropriate quadrilateral, both pairs of opposite sides equal, then say parallelogram. See, when you were in till grade 6, you only knew rectangle and square. Then if you give that answer, see, now you're in grade 6, okay? Imagine you're in grade 6. And then the teacher, at that time, the teacher asked you this question. Both pairs of opposite sides equal. Both the pairs of opposite sides are equal. Then you will say rectangle. It's right. For that standard, that answer is correct. Because you only know rectangle and square. Now you know more features, more quadrilaterals and their special features. Which one? No, both pairs of opposite sides equal. You must write parallel. Okay. All sides equal? Rhombus. No, name the quadrilaterals. Triangle. It's fine. Okay. You will not, it's not incorrect to write square. So with just this feature, all sides are equal. You can safely say it's a rhombus. You can safely say it's a rhombus. You should try to understand what I'm trying to say. Yeah, very safe answer because you know many other quadrilaterals now. So all sides equal. The safest answer is rhombus. Rhombus is the safest answer. Non-parallel sides equal. Isosceles trapezium. Non-parallel sides equal. Isosceles trapezium. One pair of opposite angles equal. Kite. One pair of opposite. In a kite, which kite? Kite? No, sorry. No, you didn't say kite. You said something else. You've written right trapezium, but in a right trapezium, one pair of adjacent angles are equal to 90 degrees, not opposite. One pair of opposite angles equal. Oh no, which one we were talking about? One pair of opposite angles equal. Only one pair. Only one pair of opposite angles equal in a kite. One pair, only one pair of, you can just include that, only one pair of opposite angles. We are not there. We are not there yet. Only one pair of opposite angles equal is kite. Both pairs of opposite angles equal? Parallelogram. Safe. Yeah, rectangle is fine. Has two right angles. Right trapezium. No. See, these statements are with respect to the the sessions we have had. Don't try to Google this. Trapezium.
Is that correct?
Trapezoid also is a trapezium, meaning the other way of calling a trapezium is a trapezoid. Has all angles unequal. No. See, you should have referred to the notes. You shouldn't Google the answer. With respect to the discussion we have had, has all angles unequal scalene trapezium. Has all angles equal? Has all, in a parallelogram, only opposite angles are equal. In a rhombus, opposite angles are equal. Only in a square and rectangle, all the angles are equal. All equal to 90 degrees. Only in a square and rectangle. Rectangle, square. Diagonals unequal. Come from the beginning. In a kite, are the diagonals unequal? In a trapezium? In a scalene trapezium, diagonals are unequal. Only in an isosceles trapezium. Yeah, I'm writing. Yes. So scalene trapezium, then what about parallelogram? Parallelogram, rhombus. Kite. In a kite, diagonals are unequal. In a trapezium, diagonals are unequal. Parallelogram and rhombus. Rectangle and square, diagonals are equal. Diagonals equal in a rectangle and square. Diagonals bisect each other. In the kite, that is bisect each other, huh? Correct. So parallelogram, rhombus, rectangle, square. Diagonals bisect each other in a parallelogram, rhombus, rectangle, square. Diagonals are perpendicular to each other. Okay. Rhombus, good. That's all. Perpendicular to each other. One more. Kite, square, rhombus. In a kite, the diagonals are perpendicular to each other. In a rhombus and in a square, the diagonals are perpendicular to each other. Longer diagonal bisects shorter diagonal. Kite. Diagonals do not bisect at diagonals do not bisect the angles at the vertices. Okay, it's time. So we'll take up this in the next class because I need to again recall the properties. Okay, so we'll see this one. Okay. Yeah, longer diagonal bisects. No, not diagonal. Okay, we'll see the last three. The others I need to. We have understood in the sessions here, but maybe you have not, like practice at home, so not able to recall. We'll see the last three. We'll take up diagonals bisecting or not bisecting the angles of the vertices. We'll, revise that again in the next class. Diagonals divided into 4 right triangles. Diagonals divided into, yeah, kite, then 4 right triangles. Four right triangles. Height, square, very good. Rhombus, kite, rhombus, and square. Kite, rhombus, and square. Wherever diagonals are perpendicular to each other, you can say this. Kite, rhombus, and square. Then 4 isosceles triangles. Rectangle and square also you can say square. Rectangle is correct. Square also. Correct. No. Rectangle and square. 4 isosceles right triangles. Square. Yeah, only square. 9, 12.